This video compares two independent population means. The response variable is quantitative, the groups are independent, and the main question is whether the population means are different. This image shows where two sample methods fit in the larger map of inference methods for quantitative response variables. The first method is students' pooled t-test. We use it when the samples are independent, the populations are approximately normal, and the population variances can be treated as equal. The null hypothesis says mu sub 1 equals mu sub 2. The alternative may be two-sided or one-sided, depending on the question. For the pooled test, we first compute a pooled estimate of the common variance. Then we use that pooled standard deviation in the t-statistic. The degrees of freedom are n sub 1 plus n sub 2 minus 2. A confidence interval for mu, sub 1 minus mu sub 2, uses the observed difference in sample means plus or minus a critical t value times the pooled standard error. If the equal variance assumption is doubtful, we use Welch's t-test instead. Welch's method still compares two independent means, but it uses a different standard error and an adjusted degrees of freedom formula. The Welch t-statistic uses s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2 in the standard error. The degrees of freedom are approximated by the Welch formula, which often gives a non-integer value. In practice, the pooled test is appropriate only when equal variances are reasonable, or otherwise Welch's test is preferred and it is often the safer default. In example 1, a marketing analyst compares sales increases for two advertising campaigns. Campaign A has a mean increase of 1.8 with standard deviation 1.0, and campaign B has a mean increase of 1.2 with standard deviation 0.6. Using Welch's test, the t-statistic is about 2.17 and the degrees of freedom are about 31. The two-sided p-value is 0.036, so we reject h sub 0 and conclude campaign A has the larger mean increase. The 95% confidence interval for mu sub 1 minus mu sub 2 is from 0.037 to 1.163. Because the entire interval is positive, it supports the conclusion that campaign A performs better on average. The key ideas are that both methods compare two independent means. The pooled test assumes equal variances. Welch's test does not, and Welch's test is usually the better default when we are unsure.